Hello students. So today I am doing class for class 12. The subject is mathematics. We are continuing the same chapter, that is determinant. So in the last class also we were doing the same chapter, that is determinant. Okay. So in the last class we did question number 20. Not question number 20, I think. Oh, yes, we did question number 20. Okay, so let's do question number 21 now. So you have to prove that. So this question is from exercise 2B. Each question carries 5 marks. Page number is 177. This page number is 177. Okay, so now each question carries 5 marks here. So you have to prove that. So question number 21. If capital A, capital B and capital C are the angles of a triangle. So what do you mean by it? A, B and C are the angles of a triangle. It is given. So we can write A plus B plus C is equal to 180 degree, or in terms of radian it is pi. So A plus B plus C is equal to pi. Okay. You have to prove that this determinant is equal to 0. That is, what is the first row here? Sin square A cot A 1. Second row sin square B cot B 1. What is the third row? Sin square C cot C 1. You have to prove this determinant is equal to 0. So now let us write down this left hand side. That is, left hand side determinant is this one. Let D is equal to this determinant. Okay. So D is equal to sin square A cot A 1. Sin square B cot B 1, sin square C cot C and 1, right? So there are 3 ones in the third column. So here also you can make any two of this one 0 by using a property. That is property number 5. Okay. So what is property number 5 here? So you can write R1 dash. That means you have to use R1 minus R2. R1 dash is equal to R1 minus R2, that is row 1 is changing. Then R2 dash is equal to R2 minus R3, that is row 2 is changing, right? So R1 dash is equal to R1 minus R2, and what? R2 dash is equal to R2 minus R3. R2 dash is equal to, it is R2 minus R3, right? So let's use these properties now. So therefore D is equal to, now what is the new first row? Sin square A minus sin square B. It is sin square A minus sin square B, right? Next, cot A minus cot B. Next one is cot A minus cot B. It is cot A minus cot B. Next one is 1 minus 1 is 0. 1 minus 1 is 0, right? So next, again R2 dash, that means row 2 is changing again. So how does it change? It is R2 minus R3, R2 minus R3, R2 minus R3, right? So it is sin square B minus sin square C. So it is sin square B minus sin square C, right? Sin square B minus sin square C. Next, cot B minus cot C. It is cot B minus cot C, right? Then comes 1 minus 1 is what? 0. So let us write here 0, right? The next, third row remains same. That is sin square C, then cot C, then the last term here is 1. That is, third row remains same. Okay. So before you simplify all these, that is sin square A minus sin square B, sin square B minus sin square C, cot A minus cot B minus cot C, let us expand it, because in the third column the two elements are 0 there. Okay. So let us expand it with respect to the third column. So therefore D is equal to, now we are using the third column for this expansion of the determinant. Okay. Now plus minus plus minus plus minus plus minus plus. So when you expand it with respect to the third column, we use plus, minus, plus, isn't it? So it is plus 0. Will you write plus 0? No. 0 into any number always 0. Then comes minus 0. Again here also 0 into any number is always 0. But you have to write 1, right? So it is 1. So within second bracket, now we have to delete the row and the column through the element 1. Since this one is considered, you have to delete the row and the column through this element 1. That means third row and third column are deleted, right? So what remains here? This term, that term, this term and this term, right? But you have to cross multiply. So first of all, you have to cross multiply this term by that term, right? That is sin square A minus sin square B, right? Sin square B, then into, then it is cot B minus cot C. It is cross multiplied. Cot B minus cot C. बुझ्दैछ? Then अब यहाँ और देना यहाँ तल गर्दै minus. Then you have to cross multiply by, you have to cross multiply sin square B minus sin square C by cot A minus cot B, right? So it is sin square B minus sin square C, right? Then it is cross multiplied by, cot A minus cot B. So here second bracket is closed. So is it understood? So this is your expansion. This is the expansion of this determinant, right? So now let us simplify it. So now you should know the formula of sin square A minus sin square B. What is that formula? So you have to prove this determinant is equal to 0, right? So what is the formula sin square A minus sin square B? I am writing the formula here. That is formula for sin square A minus sin square B. Sin square A minus sin square B. Do you remember this formula sin square A minus sin square B, which is equal to sine of A plus B into sine of A minus B. So this is the formula. So sin square A minus sin square B is sine of A plus B into sine of A minus B. So we should use this formula now. So now what is D is equal to? So D is equal to, you don't have to write this one. Okay. So now what is sin square A minus sin square B? It is sine of A plus B into sine of A minus B, right? So next, what is cot B minus cot C? You can change it into cos and sine. So cot B is cos B by sine B. Then minus, what is cot C? Cos C by sine C. Is that clear? Is that right? So what is cot B? Cos B by sine B minus what is cot C? Cos C by sine C. Next, minus. Again, what is sin square B minus sin square C? You can use the same formula out here. That is sin square A minus sin square B formula. So similarly, what is sin square B minus sin square C? Sine of B plus C into sine of B minus C. Okay. Next, what is cot A minus cot B? You can change it into cos A by sin A minus cos B by sin B. So what is cot A? Cos A by sin A minus what is cot B? Cos B by sin B. So it is simplified. Okay. So now you can write here. So you know that A, B and C are the angles of a triangle. So what can you write? What can you write? You can write A plus B plus C is equal to pi. Isn't it? So A plus B plus C is equal to pi. You can write it from given. That is A, B and C are the three angles of a triangle. So sum of the three angles of a triangle is equal to 180 degree, or it is pi. Okay. So sine of, now instead of a plus b, what can you write? What is a plus b is equal to, c is taken to the right hand side, so it becomes pi minus c. So instead of a plus b, what can you write? Pi minus c. So it is sine of a minus b, right? So what's the LCM out here? What's the LCM? It is sine b, sine c. It is sine b, sine c is the LCM. So this LCM is divided by sine b. Sine b gets cancelled, you get sine c. So sine c is multiplied by cos b. That is, you can write here sine c cos b minus, again this LCM is divided by sine c. Sine c gets cancelled, you get sine b. Sine b is multiplied by cos c. That is cos c, it is sine b. Is that clear? Now again, sine of b plus c is there. So what will we write instead of b plus c? B plus c is equal to pi minus a. A is taken to the right hand side, so it is pi minus a, right? So minus sine of, what is b plus c here? It is pi minus a into sine of, this is b minus c, right? So our into, now continuation part, what's the LCM? What's the LCM? Sine A and sine B? It is sine A, sine B. It is sine A into sine B, right? Now again this LCM is divided by sine A. Sine A gets cancelled. Sine B, it remains sine B into cos A. Cos A sine B, or sine B cos A, right? Then next minus, again this LCM, sine A sine B is divided by sine B. Sine B gets cancelled, so remain sine A. So sine A into cos B. So it is sine A into cos B. Okay. So now let us simplify it once again. Therefore D is equal to, what is sine 180 minus C? You know this formula. Sine 180 minus C lies in the which quadrant? Second quadrant. So in the second quadrant, sine is always positive. So 180 degree means even multiple of 90. So sine remains as it is. So it is sine C. Sine C into, this is sine of A minus B into, okay. Now here, what is the formula? Sine A cos B minus cos A sine B, isn't it? Sine A cos B minus cos A sine B. Right? Sine A cos B minus cos A sine B. What is the formula? Instead of it, there is C. So it is sine of C minus B. This whole divided by sine B sine C. It is sine B sine C. Is that clear? Next, minus. Again, here also, what is sine 180 minus A? Again, that is the formula is sine A, isn't it? Pi minus A lies in the second quadrant. In the second quadrant, sine is always positive. So positive and negative is negative. So 180 is even multiple of 90. So sine remains as it is. Sine does not change. So it is sine A. Sine A, sine of B minus C. It is kept as it is into, what is the formula in this case? It is again sine A cos B minus cos A sine B. Here A is B and B is A. So it is sine of B minus A. It is sine of B minus A whole divided by sine of B minus A whole divided by what? It is sine A sine B. It is sine A sine B. So LCM, that is denominator, is kept same, right? So here sine C gets cancels. Here also sine A gets cancelled. So write down the remaining terms. So what is D is equal to? Sine of A minus B into sine of C minus B divided by, it is sine B, right? Next, minus sine of B minus C, okay? Then sine of B minus A sine of b minus a, this whole divided by, it is sine b. Okay? So now, let us make it b minus c. This is a minus a, keep it as it is. Okay? So c minus b लाई हामी b minus c बनाउँछौँ. यो b minus c लाई त्यतिकै राख्छौँ. So b minus a लाई के बनाउँछौँ? a minus b by taking minus common. Right? So now, therefore d is equal to, this is sine of a minus b into, here sine of, within second bracket, here minus is taken common, so make it b minus c whole divided by sine b. Is that clear? Similarly, in this case b minus a is there, make it a minus b by taking minus common. So minus sine of b minus c into sine of, within second bracket, again from there b minus a you can take minus common. So minus within bracket a minus b whole divided by, in the denominator you should write, what is there? It is sine b. Is that clear? So therefore d is equal to, now what's about sine of minus theta? What can you say about sine of minus theta? Sine of minus theta is always minus sine theta, because minus theta always lies in the fourth quadrant, and in the fourth quadrant sine is always negative, so it is minus sine theta. Similarly, what is sine of minus within bracket b minus c? It is minus sine of b minus c. So minus, write it in the front. So sine of a minus b into sine of, this minus sign is taken outside, so it is sine of b minus c, this whole divided by sine b. Right? Next, again this is in the form sine of minus theta. Again minus sign is taken outside, so minus into minus is plus. So sine of b so sine of b minus c remains same, but in this case it is sine of a minus b, this is sine of a minus b whole divided by, it is sine b. Is it clear now? Now these terms are same, isn't it? Sine of a minus b, sine of a minus b, sine of b minus c, sine of b minus c, in the denominator sine b, sine b, but they are opposite sign. You can cancel both this term. That means, what is the value of d? So what is the value of d now? Therefore, d is equal to 0. Proved. So I have proved that LHS is equal to RHS. So d is equal to 0. Proved. Understood? Now we'll do the next question. Now we will do question number 22. Question number 22 is, without expanding, prove that. You cannot expand here. Okay? That means you have to use the properties of determinant here, then you can prove this left hand side is equal to 0, right? So here in the first row it is given that 7, 12 minus 3, 9, 14 minus 1, and in the third row 8, 13 minus 2. So let us write down this left hand side as d. So d is equal to this first row, second row, and this is third row. So without expansion we have to prove that this determinant is equal to 0. So let us do it. So if you do 9 minus 7, 2, isn't it? 14 minus 12, 2. 14 minus 12 is 2. Minus 1 plus 3 is also 2, isn't it? So let's do R2 dash is equal to R2 minus R1. Okay? Now next, R3 dash is equal to, you can do R3 minus R2 or R3 minus R1. Right? Let's do R3 minus R1. Because it will be positive. If you do R3 minus R1, you will get positive. But if you do R3 minus R2, you will get negative sign. Let's have positive sign here. Okay? That is R3 dash is equal to R3 minus R1. Right? So let's do R2 dash is equal to R2 minus R1 R2 minus R1, and next one is R3 dash. R3 dash is equal to what? R3 minus R1. It is again R3 minus R1. That means we are using the properties R2 dash. New row 2 is equal to R2 minus R1, and R3 dash, that is new row 3 is equal to R3 minus R1. Okay. Now here row 2 and row 3 are changing, but row 1 remains same. So therefore what is D? So D is equal to, what is the first row out here? 7, 12 minus 3, right? What is R2 minus R1 now? 9 minus 7, 2. 14 minus 12 is also 2. Minus 1 plus 3 is also 2, isn't it? So we get 2 here. Similarly, what is R3 dash? Is equal to R3 minus R1. R3 minus R1. 8 minus 7, 1. 13 minus 12, 1. Minus 2 plus 3 is also 1. Right? So now what will you do in the next step? So in the second row, what is common there? 2 is common there. So you can take it outside determinant. So therefore D is equal to 2 is taken outside because 2 is common in the second row. Right? So first row 7, 12 minus 3. Right? So here 2 is taken common. This is 1, 1, 1. Again, what is the third row? 1, 1, 1. Right? So here in this determinant, 2 rows are identical. That is second row and third row are identical. So what can you say about the value of the determinant? It is 0, because from the properties of determinant, in the third property we have if 2 rows or 2 columns of a given determinant are identical, then the value of the determinant is always 0. So therefore D is equal to 2 into 0. What is 2 into 0? That is D is equal to 0. Proved. Right? So what is the reason here? Why the value of the determinant is 0? Since 2 rows are what? Identical. Since the 2 rows are identical, so the value of the determinant is 0. So 2 into 0 is always 0. So we prove this, number 22. Okay. So let's do next question. So now we will do question number 23. Here also, without expanding, you have to prove this LHS is equal to 0. So here the third determinant is given as, third order determinant is given as, first row 1 BC, BC, B plus C. Second row 1 CA, CA, C plus A. What is the third row? 1 AB, AB within bracket A plus B. So here also, without expansion, you have to prove this result. That is, LHS is equal to RHS. That is, given D is equal to 0. So let us write down the given determinant again. Okay, you should write down the given determinant as D is equal to this left hand side. So what is the method now? So now, in the first row, A is missing. There is no A here. In the second row, which one is missing? B is missing. And in the third row, what is missing there? C is missing. So let us multiply the first row by A. But we are multiplying ourselves. हामी आफै A ले multiply गर्दैछौँ. त त्यसलाई क्यान्सल गर्न अगाडि के लेख्छ? 1 upon A. Second row मा B is missing. So multiply it by B. But we are multiplying ourselves by B. You should cancel it. So अगाडि के लेख्छ? 1 by B. In the third row, C is missing. So multiply all the elements of the third row by C. But you should cancel that C. So already determinant में के लेख्छौं हामी 1 upon C. Is it clear? So let's write down this one. So therefore D is equal to 1 upon ABC. D is equal to 1 upon ABC, right? Now, this first row is multiplied by A. So let us write down A. A into 1 is A. A into BC, ABC. In the third element of the first row, you should write A, B, C, then it is B plus C, right? So first row is multiplied by A, and you should cancel that A. So we have written here 1 upon A, right? Now in the second row, by which term will you multiply all the terms of the second row? By, you should multiply it by B. So what do we get? It is B. So ABC again here it is ABC. It is multiplied by B here. So ABC, so it is C plus A, right? But you should cancel that B. So here in the front, that is outside determinant, we have multiplied by 1 by B. So similarly, in the third row, C is missing, so multiplied by C, okay? So it is C, then ABC again here, then here also ABC, so this is A plus B, right? But you can cancel that C. So how can you cancel it? So before determinant, you should write 1 by C, so that you can cancel that C. Is that clear? So determinant sign is closed now. Now what will you do? Now you can take common here. We can take common from the second column and from the third column. What is common there? In the second column, ABC is common, and in the third column also ABC is common. Let us take it outside determinant. So therefore D is equal to, from here ABC, and from here ABC. What is ABC into ABC? ABC whole square, right? So it is ABC whole square divided by ABC, right? What is the first column? First column remains same. Now what is the second column? From the second column, ABC is taken common, right? So it is 1, 1, 1. And from the third column also, ABC is taken common, right? So it is B plus C, C plus A, and this is A plus B. Is that clear to all of you? So now ABC and A square gets cancelled here. Now let us simplify it. So therefore D is equal to, here it is ABC, first column ABC, second column 1, 1, 1, and what is the third column here? B plus C, C plus A, and what? A plus B, right? Now what will you do in the next step? So in the next step, what can you do now? So now this is B plus C and this is A. This is C plus A and this is B. This is A plus B and C. We can do C3 plus C1, isn't it? What is C3 plus C1? A plus B plus C. C plus A plus B is also A plus B plus C. This is also A plus B plus C. Correct? So let us do, and you can take that common A plus B plus C. Okay? And this will be 1, 1, 1. And the second column and the third column are same. So the value of the determinant is 0. Okay? So now C3 dash is equal to C3 plus C1. Therefore D is equal to ABC. Now only column 3 is changing, right? First column remains same, second column also remains same. Now third column changes. So how does it change? B plus C plus A means A plus B plus C. Similarly, what is the second column of the new third? What is the second element of the new third column? What is the second element of the new third column? C plus A plus B. That is also A plus B plus C. So what will be the third element of the new third column? What is the third element of the new third column? What is that? A plus B plus C. Okay. What is the third element of the new third column? This is A plus B plus C. This is also A plus B plus C. Right? So here the third column of this determinant is changed, right? That is A plus B plus C, A plus B plus C. It is also A plus B plus C, but it is common there, isn't it? So you can take it outside determinant. You can take it outside the determinant now. So therefore D is equal to ABC within bracket A plus B plus C from the third column. From the third column, A plus B plus C is taken common outside determinant, right? So first column A, B, C. What is the second column? 1, 1, 1. What is the third column? Third column is also, this is 1, 1, 1, right? If A plus B is taken common outside, so this third column changes. That is, it is 1, 1, 1, right? So now, these two columns are identical. If the two columns are identical, we know that the value of the determinant is always 0, right? So therefore, D is equal to ABC within bracket A plus B plus C into what is the value of this determinant? It is 0. So what is the reason? Since two columns are what? Identical. Since two columns are identical, so the value of the determinant is 0. That is ABC into A plus B plus C into 0. So therefore D is equal to 0 into any number is always 0. So it is proved. So I think I've understood it. So this is very, very important question. Mark it. Okay. So now let's do the next question again. Let's do question number 24 now. Here also, without expanding, prove that this determinant is equal to 0. So what is the determinant here? Log of, this is logarithm. Log of xyz base x, log y base x, log z base x, log xyz base y, 1 log z base y. This is log xyz base z, log y base z, and this is 1. You have to prove this determinant is equal to 0. So let us write down the left hand side determinant, that is D is equal to this determinant is again written out here. Okay. So now you should know the properties of determinant. I think you know it, isn't it? If you have log A base B, how can you write it? Log A base B, it is defined as log A upon log B. Okay. If we have log x base x, what is the value of log x base x? Actually it will be, if you write in terms of fraction, it will be log x by log x. What is log x by log x? That is always 1. Clear? So its value is always 1. Now in this case, log of xyz base x is there. You can write it in terms of fraction. Log xyz divided by log x. Here also you can write it in terms of fraction. This is also in terms of fraction. This is also in terms of fraction, but this is 1. You can write here. Here the base is y, isn't it? So here you should write log y base y, because log y base y is always 1. Here also you can write it in terms of fraction. Here you can write it in terms of fraction, and instead of 1, what will you write? Here the base is z. So what will you write for 1? Log z base z, which is equal to 1 always, isn't it? So you know this property, okay? So therefore D is equal to, now D is equal to log of x, y, z, the base is x, log y base x, log y base x, then log z base x, then log z base x, right? So now second row, log x, y, z base x. So what will you write for this one? You will write log y base y, isn't it? Sorry, this is y. Sorry, this is y. Okay, instead of 1, what will you write? It is log y base y, right? And log z base y. This is log z base y. Is that clear? Now similarly, what is the third row here? Log x, y, z base x, oh sorry, this is base z, then log y base z, log y base z, and then instead of this one, what will you write? Since the base is z here, log z base z. So you should write here log z base z. Is it clear to all of you? So now, in the next step, what will you do? You write each and every term of the determinant in terms of fraction. You प्रत्येक टर्मलाई नै अब हामी केमा लेख्छौं in terms of fraction मा लेख्छौं. So therefore d is equal to, what is the first row now here? Log xyz divided by log x, right? This is the first term. Then what is the second term of the first row? It is log y divided by log x, right? What is the third element now? Log z upon log x, right? Similarly, you can write down the terms. You can write down the terms in the second row and in the third row in terms of fraction, right? So it is log of xyz divided by what? Log y, right? Next, log y upon log y, log y upon log y, but don't cancel it, don't write 1 there, okay? Then log z by log y. Then this is log z upon log y. Similarly, what is the third row here? You can write each and every term in terms of fraction, right? So log of xyz divided by log z, okay? Next, log y divided by log z. Is that clear? Log y divided by log z. Then last one is log z divided by log z. Log z divided by log z. So we got this determinant, okay? Now next, in the next step, what will you do? You can take common from each row. From the each row, that is from the first row 1 by log x is common, from the second row 1 by log y, and from the third row 1 by log z. They are taken common. So therefore d is equal to, what is d is equal to? 1 upon log x, log y, log z is taken common, right? So what is the first row now? What is the first row now? It is log xyz, log y, log z, right? Because 1 by log x is taken common from the first row. So what will be the second row? From the second row 1 by log y is taken common, isn't it? So it is log xyz, log y, log z, right? Similarly, from the third row 1 by log z is taken common, right? So 1 by log z is taken common. So what is the new third row? It is log xyz, log xyz, this is log y, and this is log z, okay? So what do we see here? In this determinant, all the 3 rows are identical, but the value of the determinant will be 0 if at least 2 rows are identical. That means 2 rows are already identical here. So what is the value of this determinant? It is always 0. So without expanding, this determinant is always 0 because here 2 rows are identical. So therefore d is equal to 1 upon, it is log x, log y, log z into what? 0. That means d is equal to 0 divided by n number is always what? 0. So it is proved. Is it clear to all of you? So this is the answer. Now we'll do the next question now. Let's do question number 26. Prove that this determinant is equal to ABC into A square plus B square plus C square whole cube, right? Let us prove LHS is equal to RHS. What is the given determinant here? D is equal to, what is the first row? minus a within bracket b square plus c square minus a square. This is the first element. 2b cubed. Second element 2c cubed. Third element. In the second row, what is the first element? 2a cubed minus b into c square plus a square minus b square. Second element 2c cubed. Third element. And in the third row, 2a cubed. First element 2b cubed. Second element, and minus c into a square plus b square minus c square is the third element. Right? So let us simplify it. But you should prove on the right hand side ABC into what? A square plus b square plus c square whole cube. You have to prove this result. Okay. So now what we will do here is, let us take common from the first column. What is common here? A is common. From the second column, what is common? B is common. And from the third column, what is common there? C is common. Let us take it outside. A, B and C as common. Okay. So therefore D is equal to A, B, C are taken common from the first row, second row and the third row respectively. So now it becomes, now multiply by minus sign here, minus into minus plus, A is taken outside, minus into minus plus, A square minus B square minus C square. So it is 2A square, this is also 2A square because A is taken common outside. From the second column also, what is common there? B is common, B is already taken outside. So it is 2B square. Next, this one, B is already taken common. So multiply by minus sign here, it will be B square minus into minus plus B square, then minus C square. Minus into plus minus C square, minus into plus minus A square, right? So what is the third element of the second column? It is 2b square because b is already taken common. So it is 2b square, right? I think you have understood it. Okay. So next, what will you do now? It is 2c cubed. Now c is taken common here. C is taken common from the third column. So it is 2c square. This is also 2c square. C is taken common. From here also c is taken common outside. Isn't it? C is taken common outside, right? So what does it become now? So minus into minus plus c square, then minus a square, that is minus into plus minus a square, then minus into plus minus b square, right? So this is the simplified determinant. So now what will you do? You should get now on the right hand side one of the factors as a square plus b square plus c square, right? So what will you do with this determinant now? You can use the property here. So let's check it. If you do c1 plus c2 plus c3, that is c1 plus c2 plus c3, all the columns are added. That is c1 plus c2 plus c3. So what do we get here? If we add all these elements in the first row, a square minus b square plus 2b square plus b square minus c square plus 2c square, that is this is plus c square. This is a square plus b square plus c square. Similarly for the second row, if all these terms are added, what do we get? Let us check it. 2a square minus a square plus b square plus 2c square minus c square plus c square. That means we are getting a square plus b square plus c square here also. Now add all these elements in the third row. What do we get? Let us check. 2a square minus a square, 2b square minus b square plus b square, and this is plus c square. That means here also we are getting a square plus b square plus c square. That means in the first column all the elements are same. That is a square plus b square plus c square. That means you can take it outside. Is that clear? So now, so let us use this property now. So c1 dash is equal to c1 plus c2 plus c3. Therefore D is equal to, now it is ABC. What is the new first column now? It is c1 plus c2 plus c3. What do we get? A square minus b square plus 2b square plus b square minus c square plus 2c square plus c square. Okay? Again c1 plus c2 plus c3. That is all the elements in the second row are added. 2a square minus a square. This is plus b square. Then plus 2c square minus c square plus c square, right? Next, what will you do? Again, all the terms of the third row are added. So 2a square minus a square plus 2b square minus b square plus b square plus this is c square, right? So this is the new first column, that is c1 dash is equal to c1 plus c2 plus c3. So what is the second column? Second column remains same, 2b square b square minus c square minus a square, and this is 2b square, right? Next, third column remains same, again here 2c square, and this is c square minus a square minus b square, right? So this is the determinant, okay? Now what will you do in the next step? You can take common from the first column, right? So therefore D is equal now ABC within bracket a square plus b square plus c square, right? A square plus b square plus c square is taken common outside. What is the new first column? 1, 1, 1. So let us write down the second column. Second column remains same, 2b square, right? Next, b square minus c square minus a square. This element is kept same there. Then 2b square, then it is 2b square, right? Now what is the third column now? Third column is 2c square. This is also 2c square, right? And the last element is in the third column, what is that? C square minus a square minus b square. C square minus a square minus b square. So this is the determinant. So is it clear now? Now what do we see here? All the elements in the first column are same. That is 1, 1, 1. So you can make any two of these ones 0. You can make any two of these ones 0. Okay? So what we will do here is R1 dash is equal to R1 minus R2. Right? R1 dash is equal to R1 minus R2, or you may write R2 dash is equal to R2 minus R3 also. Let's use this property, okay? So in the third order determinant, at a time maximum 2 properties can be used. So let us use 2 properties out here at a time, okay? So R1 dash is equal to R1 minus R2, and R2 dash is equal to R2 minus R3. तो तिमीले यो नलेखेर R3 dash is equal to R3 minus R1 or R3 minus R2 लेख्यो नि हुन्छ, बुझ्यो? एउटै आउँछ आन्सर, ठीक छ? So therefore D is equal to now ABC into A square plus B square plus C square. This is common. This is outside determinant, right? So now R1 minus R2. That means row 1 is changing here. R1 dash. Row 1 is changing. So 1 minus 1 is 0. Now this minus this. 2b square minus b square. That is b square minus into minus plus c square plus a square. That is minus into minus is plus. What is 2c square minus 2c square? That is 0. Is that clear? Next, R2 dash. That means second row is changing now. So how does it change? R2 minus R3 again. So 1 minus 1 is 0. This minus this. What do we get? B square minus 2b square minus b square minus c square minus a square, right? So this minus this. 2c square minus c square, that is c square minus into minus plus a square, here also minus into minus plus b square, right? Then what do we get here? 1, this is 2b square, so that means third row remains same, isn't it? Only R1 and R2 are changing, but third row remains same. 1 2b square, then c square minus a square minus b square, right? Now you can expand it. Now we can expand it. So let us expand it with respect to the first column, okay? Because there are 2 elements, 0, 0, 0, 1 is there, right? So therefore D is equal to ABC into a square plus b square plus c square into. Now let us expand it with respect to the first column. So if you expand it with respect to the first column, you have to consider the sign also. Plus, minus, plus. So first of all, it is plus 0. Will you write 0? 0 into any number is always 0. Minus 0 also you don't have to write it because 0 into any number is always 0. But plus 1 you have to write. Plus 1. So within second bracket, what do we get? Now we are considering this one. Delete the row and the column through the element. That means third row and first column are deleted. So these terms remain. So you have to cross multiply b square plus c square plus a square by c square plus a square plus b square. That is, how much is it? A square plus b square plus c square whole square. Right? Then cross multiply by 0 into minus b square minus c square minus a square, that is 0. तर बीच में कौन से साइन हुन्छ? Minus 0. Right? It is minus 0. So your second bracket is closed. Right? So now if you take this one, you have to delete the row and the column through the element. That means third row and first column are deleted and these elements remain here. Okay, so this is the second order determinant. You know how to expand it. This into this whole square, b square minus 0 into this number is always 0. Okay, so what is the final answer? So d is equal to abc into, now this factor into this whole square. These are the same bases. If these two bases are same, if you multiply them, powers will be added. So what do you get? What is the power? 1 plus 2 is 3. So a square plus b square plus c square into a square plus b square plus c square whole square is always a square plus b square plus c square to the power 1 plus 2. Powers will be added. So it is a square plus b square plus c square whole cube. So it is good. Understood? So this question is very, very important. So you can practice it at home. Okay. Now I'll give you the homework. Now these questions are from Higher Secondary Examination 2020. So this is your homework. Okay. Now this is 1B number 2. You have to show that this determinant is equal to 0. What is the given determinant? First row is 1 log b base a log c base a log a base b 1 log c base b. Third row log a base c log b base c 1 is equal to 0. त तिमीले यहाँ प्रुभ गर्नुपर्छ this determinant is equal to 0. अघि भर्खर एउटा प्रब्लम हामीले यस्तो गरेको थियौं. That is question number 24. It is same as question number 24, right? So there is one here. This is the base A, base A. So write this one as log A, base A. Write this one as log B, base B. Now you know the method. This one should be written as log C, base C. Okay? You write on left hand side. D is equal to left hand side. Then instead of this one, you should write log A, base A. For this one, log B, base B. For this one, log C, base C. Then write all the terms in terms of fraction. You have to write all the terms in terms of fraction. Okay? And from the first row, 1 by log A common. From the second row, 1 by log B common. From the third row, 1 by log C is taken common outside. You will get all these first row, second row and third row identical, and the value of the determinant is 0. So without expansion also you can prove it. Okay? So you can do it. Now in part B, this is objective type of question. It carries only 1 mark. Okay? If omega be an imaginary cube root of 1, we have done this type of problem, isn't it? You know that if omega be an imaginary cube root of 1, if omega be an imaginary cube root of 1, what can you write? Omega cube is equal to 1 and 1 plus omega square is equal to 0. Right? So we have to use this formula. Then the value of this determinant, first row, 1 omega square omega 1 omega square 1 omega square omega 1 is what? Which is the correct option? A, B, C or D. Do it yourself. Okay? If the correct option is -1, then write A here. If the correct option is omega cube, then write B here. In the blank box, you have to write down the correct option. Okay? If it is 0, write C here. If it is minus omega square, then write d out here. Understood? So these are your homework. Okay, so this much is for today. So you can practice all the problems that we have done here. Okay, त तिमीले घरमा राम्रोसँग प्र्याक्टिस गर्नु सजिलो भइहाल्छ. ठीक छ? So this much is for today. Thank you.